Title of the first section today is Solving an Equation. First question or first equation is 2x plus 3 equals 13. To solve an equation, we want to do a few steps to get x by itself, so our final answer would be x equals the number. If we have 2x plus 3, to get x by itself, we want to first move numbers away from x to the other side. If we have a plus 3, we can do the opposite of plus 3, which is minus 3, and we'll do that on both sides. The 2x would come down. Plus 3 minus 3 would cancel out, and equals 13 minus 3, which would be 10. And the last step, 2 times x, the opposite of multiplying by 2, would be dividing by 2. And again, we'll do that on both sides of the equations. 2 divided by 2 would cancel out, and the final answer, 10 divided by 2, would be 5. So the answer to the question, x equals 5. Second question, and last question for the section. Negative 3y minus 4 equals negative 24. Solving when we want to get y by itself. And again, the numbers away from y we'll get rid of first. Minus 4, the opposite of minus 4 would be plus 4. And again, we'll put plus 4 on both sides of the equation. Negative 3y would stay the same. Minus 4 and plus 4 would cancel. Equals negative 24 plus 4 would be negative 20. Different signs will subtract. Negative 24, 24 is a bigger number, so it's negative 20. And last step, negative 3 times y. To get rid of multiplying by negative 3, we can divide by negative 3. So y equals, 3 does not divide into 20, and the fraction 20 over 3 cannot be reduced. But if we have two negatives, a negative divided by negative would be a positive, so our final answer will be 20 over 3. Title of this next section is Solving More Equations. First equation we'll solve, 1 plus a over 5 equals negative 1. This equation has a fraction. Again, we'll solve with these same steps. We want to get a by itself, so our final answer would be a equals the number. A again would stay on the left side. We want to get rid of this positive 1. The opposite of positive 1 or adding 1 would be minus 1. 1 minus 1 would cancel out. A over 5 would stay the same. And negative 1 minus 1 would be negative 2. From here, we have a over 5 or a divided by 5. The opposite of dividing by 5 would be multiplying by 5. So we'll multiply both sides by 5. multiply by 5 and divide by 5 would cancel out. So we'll be left with a, and negative 2 times 5 would be negative 10. So the answer A equals negative 10. Second question, and last question for the section. Negative 10 equals negative 6 plus 2x. This time the variable x is on the right hand side. But again, these same steps, we want to get x by itself, so we want to move the negative 6 to the other side. The opposite of negative 6 or minus 6 would be adding 6. And again, we'll do that on both sides of the equation. Negative 10 plus 6 would be negative 4. Negative 6 plus 6 would cancel, and the 2x would stay the same. Last step to get x by itself, we have 2 times x. The opposite of multiplying by 2 is dividing by 2. Negative 4 divided by 2 would be negative 2. The 2's will cancel, and we'll have the answer negative 2 equals x. Or if you want to, you could rewrite it x equals negative 2. A library doubles the amount of books they have and then adds 4,028 more books. If they end with 51,514 books, how many did they start with? To solve this question, we can write an equation and then solve for the variable. If we're looking for the number of books that they started with, we can let that be x, a variable that we can solve for. At the beginning, they took the amount of books x and they doubled the amount of books. If we double x, that would be 2x, or 2 times x. After they doubled the book, they added 4,028 more books. So to this we can add 4,028. And once they had that, they had a total, or equals, 51,514. So taking the word problem, we can write an equation using a variable like x. Solving this, we can find out what x is, or how many books they started with. Again, we want to get x by itself, so the first step, adding 4,028, we can cancel that by subtracting 4,028 from both sides. 2x would stay the same, and the adding 4,028 minus 4,028 would cancel. And subtracting these numbers, 4 minus 8, we need to borrow from the next number. The 1 we can change to a 0, and the 4 we can change to a 14. So 14 minus 8 would be 6. 0 minus 2, again we'll have to borrow from the next number. The 5 we can change to a 4, and the 0 we can change to a 10. So 10 minus 2 would be 8. 4 minus 0 would be 4. 1 minus 4, again we can borrow from the next number. 11 minus 4 would be 7, and the 4 would come down. So after subtracting, we'd have 47,486, and that's what 2x would be equal to. 47,486. Again, to solve for x, 2 times x, or multiplying by 2. We can divide by 2 to cancel that out. So we'll have x equals, and we have 47,486 divided by 2. To solve that, we can use long division. The top number or numerator we'll put inside the long division sign, 47,486. And the number 2 we're dividing by, or the denominator, goes outside the dividing sign. 2 goes in the 4 2 times, so put that above the 4. 2 times 2 would be 4. And when you divide, we'll subtract the numbers. 4 minus 4 would be 0. And then we'll bring the next number down, which is 7. 2 into 7 would be 3. 3 times 2 would be 6. And 7 minus 6 would be 1. Bringing the next number down, the 1 changes into 14 now. 2 into 14 goes 7 times. 7 times 2 would be 14. Subtracting would be 0. The next number we can bring down, which would be an 8. 2 into 8 goes 4 times. 4 times 2 would be 8. Subtracting again would be 0. And last number we'll bring down is 6. 2 into 6 would be 3. And 3 times 2 would be 6. Subtracting, which is 0, which means we have no remainder. So the answer, 23,743, is what x is equal to. 23,743. The amount of books that the library started with. Title of the first section today is Solving Equations with Fractions. In this section we'll solve equations, but the equations will contain fractions that we'll have to solve for. First equation is 5 over 7 x plus 1 over 7 equals 3. Solving this question again, we want to get x by itself, so our final answer would be x equals the answer. We're going to leave x on the left hand side. We can get rid of the fraction plus 1 over 7 by doing the opposite, which is minus 1 over 7. And again, we'll do that to both sides of the equation. 5 over 7x would stay the same. Plus 1 over 7 minus 1 over 7 would cancel. And we have the question 3 minus 1 over 7. To subtract numbers with fractions, we can first make all numbers fractions. 3 we can make a fraction by putting a 1 for the denominator. So we have 3 over 1 minus 1 over 7. If you remember before we can subtract fractions, the denominator or bottom number has to be the same. So in this case, if we have 7 and 1, the top number we can change to a 7 by multiplying by 7. And we'll multiply both the denominator, which is the bottom number, and multiplying the numerator by 7. So 3 times 7 would be 21, and 1 times 7 would be 7. So 3 over 1 we could change to 21 over 7. And we're still subtracting minus 1 over 7. So now we have 21 over 7 minus 1 over 7. Common denominators, or the bottom number, is the same, which would stay the same as 7. And we can subtract 21 minus 1, which would be 20. So the original question, 3 minus 1 over 7, would be 20 over 7. And last step for the question, we have 5 over 7 times x equals 20 over 7. If you're multiplying a fraction times a variable, a good way to get rid of that fraction is multiply by the reciprocal. A reciprocal is the same fraction, but flipped upside down. So instead of 5 over 7, we'll flip it upside down and have 7 over 5. If we multiply one side by 7 over 5, we'll multiply the other side by 7 over 5 also. When you multiply reciprocals, reciprocals cancel. We'll have 7 divided by 7, which cancels, and 5 divided by 5, which cancels. So we're left with x. And multiplying the fractions, if you wanted to, you could multiply straight across. You do not need common denominators when you multiply. A easier part on this one is we have a 7 for one numerator, a 7 for a denominator. We can cancel these out. 7 divided by 7, and we're left with 20 over 5. And if you divide 20 over 5, you'll get the answer x equals 4. Second question, and last question for the section. Negative 1 over 5y minus 2 equals 4. Again, we'll solve for y, so we'll move all the numbers to the other side, so we'll have y equals for our final answer. First step, the numbers away from y, the minus 2, we can cancel out by adding 2 on both sides. The negative 1/5 y would stay the same. Negative 2 plus 2 would cancel, and 4 plus 2 would be 6. Last step for this question, we have a fraction times a variable. Like we did in the previous problem, anytime we have a fraction times a variable, we can multiply by the reciprocal, which again is the same fraction flipped upside down. 1 over 5 would become 5 over 1, and if the fraction is negative, the reciprocal is also negative. So we'll multiply by negative 5 over 1. And again, we'll do that on both sides of the equation. On the left-hand side, the 5's would cancel. 5 divided by 5, the 1's would cancel. And also a negative times a negative would be a positive, so those would cancel. And we're left with just y. This time we have 6 times negative 5 over 1. Negative 5 over 1 is the same thing as negative 5. So 6 times negative 5 would be negative 30. So the final answer, y equals negative 30. Title of the next section is Solving Equations with Decimals. Again, this section will solve equations, but the equations will contain decimals. First question is 3.5 plus 10m equals 7.32. Again, we want to solve for m or get m by itself. In this case, the number is away from m, 3.5. We want to move to the other side first. This is adding 3.5, so we'll do the opposite of minusing 3.5. When we subtract decimals, make sure to line the decimals up. So 7.32 minus 3.5 with the decimal lined up in the middle. 3.5 and minus 3.5 would cancel. So 10m would stay the same, equals. If you want to, you can add zeros to the end of the decimal. So negative 3.5 is the same as negative 3.50, and we can subtract. 2 minus 0 would be 2. 3 minus 5, again we can't subtract, so we'll have to borrow from the next number, which becomes a 6, and then a 13 we're subtracting. 13 minus 5 would be 8, and 6 minus 3 would be 3. When you subtract decimals, the decimal comes straight down, so we'll have 3.82. And last step, 10 times m, or multiplying by 10. Opposite of that would be dividing by 10. So the 10s would cancel. If you wanted to, you could use long division. 3.82 divided by 10. One shortcut, when you divide by 10, you can move the decimal one spot to the left, and that would be the answer from dividing by 10. So we'll have 0.382, and we can put a 0 in front of the decimal point. So m equals 0.382. And again, when you divide by 10, just move the decimal to the left one spot, and you'll get the correct answer. Second question, and last question for the section. 0.4x plus 9.2 equals 10. Again, solving for x, the numbers away from x, adding 9.2. We can cancel that by subtracting 9.2 on both sides. If the 10 does not have a decimal, we can add a decimal after and also put a 0. 0.4x would stay the same, equals. And subtracting decimals, 0 minus 2 we can't subtract. We can't borrow from the 0, but we can borrow from the 1, which will make this 0 a 9 and make the first 0 a 10. So 10 minus 2 would be 8. 9 minus 9 would be 0. And the decimal point, again, comes straight down, so we'll have 0.8. 0.4 times x equals 0.8. To get rid of a decimal that we're multiplying by, 0.4, we can divide by 0.4. 0.4s would cancel. X equals, we'll divide the two decimals, 0.8 and 0.4. If you set up a long division question, the numerator or top number goes inside, 0.8, and the denominator or bottom number goes outside, 0.4. If you remember, when you divide decimals, you can have decimals inside the division symbol, but you're not allowed to have decimals outside before you start the question. So what we can do is move this decimal to the right one spot, and if we move the decimal one spot on the outside, we'll move it also one spot on the inside to the right. So instead of 0.4 going into 0.8, now we have the number 4 into 8. So 4 goes into 8 two times. 2 times 4 will be 8. Subtracting will have no remainder, and the answer would be 2. So x equals 2. Temperature increases 10 degrees Celsius for every kilometer below the Earth. If the temperature is 22 degrees Celsius, how far down is a coal mine if its temperature is 45 degrees Celsius? Again, for this word problem, we can write an equation and solve for a variable. We're looking for the temperature, or how far down the coal mine is. How far down the coal mine is can be represented by x. Temperature increases 10 degrees Celsius for every kilometer. Again, x is the distance in kilometers. So if it's 10 degrees for every kilometer, that would be 10 times the number of kilometers, or 10 times x. If the temperature is 22 degrees to start with, that means we'll add 22. And the question is, how far down is a coal mine? If the temperature is 45 degrees Celsius, that means the final temperature at the coal mine will be 45. So the equation 10x plus 22 equals 45, and we can solve for x. Again, the numbers away from x plus 22 we can cancel by subtracting 22 on both sides. So 10x would come down. 45 minus 22. We can just subtract 5 minus 2 would be 3, and 4 minus 2 would be 2. So we have equals 23. 10x equals 23. To get rid of the 10 in front of the x, we can divide by 10. And our final answer will be x equals, the fraction does not reduce, 10 does not go in evenly, so we can leave it as 23 over 10. If you wanted to, you could divide by 10 again by moving the decimal one spot or using long division, and it would come out to x equals 2.3. So the coal mine is 2.3 kilometers below the earth. Title of the first section is Solving Equations by Combining Like Terms. In this section we'll solve equations, but we'll first combine like terms. First equation is 4n minus 2n equals 18. At the beginning of this question, we have like terms. Again, like terms are the same variable with the same exponent. 4n minus 2n. If we combine those, would be 2n. 4 minus 2 would be 2, and the variable stays the same. So 2n equals 18. And last step, to get rid of the 2, we can divide by 2. And n is equal to 9. Second question, and last question for the section. Negative 2y plus 5 plus 5y equals 14. Again, check to see if we can combine like terms. We have the same variable y on the same side of the equation, so we can combine those. Negative 2y plus 5y would be 3y. Negative 2 plus 5 is different signs, so we'll subtract 5 minus 2, which would be 3. The 5 is bigger, so it's a positive 3. The plus 5 stays the same and equals 14. Solving from here, the opposite of plus 5 would be minus 5 on both sides. 3y stays the same. 5 minus 5 cancels. And 14 minus 5 would be 9. And last step, we can divide by 3, and y is equal to 3.